Hey everyone, this is the 2016 FRQ question number 3. So we're given the graph of f, and that's this piecewise function. And then we're given that g of x is equal to the integral from 2 to x of f of t dt. So g of x is this accumulation function. Whenever I do accumulation functions, I like to find my first and second derivatives right away because I know I'm going to need them. And it also helps me get a bigger idea, bigger picture of what's really going on in this problem. So for g prime of x, I'm just going to take the derivative of that integral. And so I'm going to apply the fundamental theorem of calculus, and it actually ends up just being f of x. So that means this graph of f that I'm given, I'm really given the graph of g prime. And then g double prime of x is going to be f prime of x, which really means I can just look at the slope that's on the graph, and that'll tell me about the second derivative. So does g have a relative min, relative max, or neither at x equals 10? In order to have a relative min or relative max, we know that we need the first derivative to change signs. So does the first derivative change signs at x equals 10? And if we look right here, it does not. So g has neither a min or a max. Wow, guys, there is something wrong with me today. This is like the fourth time I've tried to make this video, and I can't spell. At x equals 10 because g prime, which is equal to f, does not change signs at x equals 10. This one here was worth 1 point because it was really just did you get your answer and justify it. Part B asks us if the graph of g has a point of inflection at x equals 4. So we know for a point of inflection, we have to think about the second derivative, which is g double prime. And we said that's equal to f prime, which we know is the slope of f. And to have a point of inflection, we need the second derivative to change signs. So we want to know, does the slope of f change signs at x equals 4? Well, at x equals 4, f had a positive slope and then a negative slope, so yes, it did change signs. So the graph of g has a point of inflection at x equals 4 because g double prime, which is equal to f prime, changes from positive to negative. At x equals 4. So I guess we should actually say yes. This one was also just worth 1 point. So did you get your answer and did you justify it? Part C and D are the ones that are definitely more involved in this problem. So part C asks us to find the absolute minimum and absolute maximum. In order to do that, we have to make a table, right? In order to find an absolute, we know we need the endpoints and the critical values. So the endpoints we know are -4 and +12. We have to look at the graph and find the other critical points. So critical points mean we want the first derivative to be equal to 0. And since this is the graph of f, which is really the graph of g prime, we're just going to look at those x-intercepts. But more specifically, in order for it to be a min or a max, we know that the first derivative has to change signs. And at 2 and 10, we know that it doesn't. So we really only have to worry about using -2 and +6 in our table, in addition to our endpoints. So we're going to have x, g of x, and we're going to start at -4. We're going to have a critical value at -2, +6, and then 12. All right, so in order to find these values, we're going to need to use this integral, right? So to find g of negative 4, it means we're going to do the integral from 2 to negative 4 of f of t dt. So we can see that that integral is actually written backwards. So I'm going to make it negative and go from negative 4 to positive 2. And so let's see what we end up getting here. The integral from negative 4 to positive 2. So I'm going to get rid of some of this other stuff that's up here. Negative 4 to positive 2. So we've got this triangle and then this triangle. And we can see that that first one is under the x-axis. So it's actually going to be negative again. So negative 1/2. The base is 2 and the height is 4. And then plus 1/2, the base is 4 and the height is 4. And so we've got negative, let's see, that first part becomes negative 4 and then plus 8. So that becomes negative 4 overall. So I'm going to write that up here. That's our first function value. And then for 2, we're going to do the same thing. We're going to do the integral now from 2 to negative 2 of f of t dt. And so since that integral is backwards, I'm going to make it negative and flip my bounds. So it's going to be negative, and then let's figure out what that area looks like. So we're just doing from negative 2 to 2 this time. So from negative 2 to positive 2 is just this triangle that's on the top there. So that's going to be 1/2. The base is 4 and the height is 4. And so we would get negative 8 as our answer for that one. For 6, we're going to do the integral from 2 to 6 of f of t dt. So let's see what that looks like. 2 to 6. So starting at 2, going to 6, that's just this triangle. So that's going to be 1/2, 4 times 4. So that's going to be a positive 8. And then finally, we have the integral from 2 to 12 of f of t dt. And so now, let's look here. I'm going to get rid of this one. And that one, sorry. And we're going to do the integral from 2 to 12. So we have this triangle that's on top, this triangle that's on the bottom, and then another triangle on the bottom. So let's see, that's the same as the one before, so it was 8, right, to go from 2 to 12. And then we would have plus, the next one is a negative, 1/2, 4 times 4. And then another negative 1, now it's 1/2, the base is 2 and the height is 4. So let's see, it becomes 8 minus 8 minus 4, so we get negative 4. And so remember, for this problem, we're looking for the absolute minimum and absolute maximum. So I'm going to do it in a different color so that it stands out a little bit more. So the absolute minimum would be negative 8, and that happens at x equals negative 2. And then we would have the absolute max is positive 8, and that one is at x equals 6. So this is really the answer that we're looking for here, and all of the work that I showed there is the justification for it. All right. Just as a quick side note, this one is worth 4 points. I'm not going to break it down for you because there's already so much work here. But this was worth 4 points. It was a point for including the -2 and the +6 in your table. It was a point for including -4 and +12 in your table. So it's really 2 points for having all four of these x values here, and then it's 2 points for your answers with all your work. Okay, part D here is a little confusing. So part D asks you for all of the intervals for which g is less than 0. And we know that g is this accumulation function, right? G of x is equal to the integral from 2 to x of f of t dt. So in order to figure out where that's less than 0, we're going to have to analyze what's going on here a little bit. Well, hopefully you can recognize that at x equals 2, g of x is going to be equal to 0. All right, if we go the integral from 2 to 2, that's going to give us an area of 0, which means if we were to plug in anything that's to the left of 2, we would have a negative value for g of x. So what that means is the first interval that we could say would be -4 to +2. And I'm going to look at that graph again just really quickly to kind of explain that a little bit. So we know that right here at x equals 2, the area is going to be equal to 0. And if we do an integral going backwards, it's going to give us a negative area. So anything starting at 2 and moving towards the left is going to give us a negative area, which really means anything from -4 to +2 is going to give us a negative value for g. So that's our first interval that we're going to deal with. And then the second one, let's see. If we start at x equals 2 and we travel this way, up until we get to 6, that's going to be a positive value because of this triangle that's on top, right? Anything there is going to give us a positive area. Well, if we look, this triangle, oops, sorry, this triangle underneath is the exact replica of this one up here, right? These two triangles are actually the same. So to go from -2 to 10, we're going to either have a positive area, and then once, well, it's going to be a positive, and once we get to 10, the area is going to be 0 again. Then once we keep going from 10 to 12, we can see that it's going to be a negative area. So the other integral then is going to be from 10 to 12. Hopefully that makes sense. For this one, you didn't have to include any justifications there. This was just worth 2 points. It was 1 for each interval. And then this problem was a little different. If you add all those up, you'll notice we only get to 8. For this problem, it was 1 point for overall. Did you remember to put that g prime of x is equal to f of x on all of your justifications? So especially for parts A and B, did you remember to include both parts there? That was worth a point. Okay, I know that one was a little tricky and a little hard to understand, especially part D. So if you have any questions, please just reach out. All right, thanks for watching.